Hello, class 12th physics, chapter electromagnetic waves. I'm just including those topics which are included in um, CBSE 2021 session only. All right, so here I'm starting with the electromagnetic wave spectrum, and from here we'll start and move on. So, what is electromagnetic wave spectrum? Actually, there are a number of electromagnetic waves, and we have categorized them into different groups. So, here they are, and those groups are called spectrum, electromagnetic wave spectrum. So, here we have an acronym for that, RAM IVU XG. So it is much easier to memorize it. Some people call it RAM I love you XG, but okay, in which way you want to memorize it? RAM I V U XG. So RA stands for radio waves, M stands for microwave, I stands for infrared, and from here we start using the term ray. V visible, some people call light or visible ray, that is why I love you comes here. U ultraviolet ray, X X-ray, G gamma ray. Now their wavelength ranges. So radio wave, just imagine radio waves are from their ranges from 10 to the power minus 1 meter to 10 to the power 4 meter and above. Till now up to 10 to the power 5 even 6 meter long wavelength um, is discovered, is created. Microwave 10 to the power minus 3 to 10 to the power minus 1 meter, this will come here, and so and so and so. Infrared 10 to the power minus 6 to 10 to the power minus 3 meter. Visible, here see, here I am just using the order of magnitude just in terms of power. So their boundaries are intermixed now. But if we talk about a radiation of 10 to the power 3, then we have to include it in this category. So we can say it is one side open interval. Okay, visible, here we have some accurate values, like, okay, 4 into 10 to the power minus 7 meter to 7 point something. Actually I'm writing 7, actually we can write 8 also. 10 to the power minus 7 meter. Ultraviolet 10 to the power minus 7 to 10 to the power minus 9, sometimes 10, but 10 is not included in ultraviolet. X-ray 10 to the power minus 9, which is not included in X-ray, to 10 to the power minus 12 meter. So why don't I write 10 here? But it is not included, and here it is included. And gamma 10 to the power minus 12 to 10 to the power minus 15 meter. So on the basis of this we can calculate frequency range. I'm not going to calculate it, but I can tell you how you people can calculate it. So for this, what you people can do in very easy way is C equal to nu lambda, we know. So nu equal to C by lambda. And as we are interested in just the order of magnitude, so instead of c is 3 into 10 to the power 8, but in terms of order of magnitude we'll just consider 10 to the power 8 only. So if I want to write the range of radio wave, then nu equal to, in the place of c, 10 to the power 8, and upon lambda, this is the lambda, 10 to the power minus 1, so it will be 10 to the power 9 hertz. And what about this? So nu equal to 10 to the power 8 upon 10 to the power 4, that is 10 to the power 4 hertz. So its frequency range will be 10 to the power 4 to 10 to the power 9 hertz. And uh, and so and so. Here, okay, for visible, we can't use just the order of magnitude term. So here we have to calculate it properly, and see how nicely you can memorize those values also. Nu equal to C by lambda. Lambda is here 3 into 10 to the power minus 7. Oh, sorry, 4 into. So it will be equal to 0.75 something into 10 to the power 15. And when we rearrange it, 7.5 into 10 to the power 14. So round about 8 into 10 to the power 14. So it's and for this it will be 7 upon 4. I'm directly writing 10 to the power 15, and when, oh my god, 3 by 7, and when we divide it, so it will be 4 point something into 10 to the power 0.4 something actually. So later on it will be 4 into 10 to the power 14. So the range will be, the range, frequency range will also be 4 into 10 to the power, actually this relates with this, actually it is not related to this, it is related to this, 14 to somewhere 8, 7. So you can just for the memorization purpose you can write 7, 7 into 10 to the power 15 hertz. Okay, now rest of it is a drill for you people. All right, now production, how these waves are produced. So radio wave are produced by LC circuit. Microwave, so there are name of device is clysteron and magnetron. Infrared by hot bodies, sun, laser, and so on and so forth. Visible, so there is LED, incandescent lamp, I'm just writing lamp, sun, and so and so. There are so many sources we know about it. Ultraviolet, all right, so ultraviolet, spark, sun. So we can see infrared, visible, and ultraviolet. For all of them, the sun is the source. Then ultraviolet, then X-ray. Its source is bombardment of fast moving electrons on heavy metal. Gamma, radioactive origin. All right, so their detection. So for detection, okay, this is series LC circuit and this is parallel LC circuit. So it is produced by LC circuit, detected by LC circuit. All right, microwave, they have some special purpose solid state devices like pin diode. So just memorize, don't care what is it, just avoid those things. Infrared, it is detected by thermopile, thermal sensors. Thermal sensors. Visible, best detector is eye. And other than that, photocells, photometers, and all that. Photodiodes. All right, ultraviolet. So it's detection by photosensitive screen. In fact, infrared, visible, and ultraviolet, they all give effect on photosensitive screen, but their impact can be distinguished from one another. X-rays, X-ray, where it is produced, so also it is detected in the same way on photographic plate, film. And there are some detectors called Geiger detector, Geiger actually. And gamma, again Geiger detector. Cloud chamber, these are made to trace these radiations. Okay, so next is their uses. So radio wave is used in radio and television communication. Microwave is used in radar. So this is for radio wave. Now for microwave, one and only. And here one, radar. Second, to cook food in microwave ovens to cook. Here I want to tell you that how microwave is used to cook. So remember, heating effect is produced by infrared, not by microwave. But what does microwave do? It vibrates water molecules, and which are present in the food items. So that is why, because of their vibration, they heats they heat up and they heat their surroundings, and hence the food gets heated. So remember that thing, that microwave are not the heat waves, but they heats water molecules. All right, they are used in satellite communication. All right, so next, infrared. These are mainly used to cure muscle strain. Second thing, to warm up the earth. In remote controls, thermal scanners, night vision. Oh, its uses are so much. Actually, I have limited space, so that is why I have to move here. Fifth point, night vision devices. Actually, a few night vision devices use some other properties also, but most of them are based upon infrared technology. Next is visible. Oh, to see. Uh, Second, photography. Third, lightning purpose. Or in fact, just to see, it all comes in that form. One more we can write in optical fiber communication. So in optical fiber communication, it is light signal actually, so that travels. Okay, ultraviolet. So I think you people might have seen that ad of Kent RO. So in that they often say it has UV filtration technology. So UV is used to kill germs, to kill germs. So where it kills germ, it kills germs in water purifier, or in packaged food industry, water purifier and packaged food industry. Okay, less space, so I am utilizing till here, from here. So second use, it forms, if ho gaya, it forms ozone layer in the outer atmosphere, which protects us from itself, from ultraviolet. So ultraviolet forms that layer and protect us from ultraviolet. So this is also important use of ultraviolet. It forms ozone layer. Third, okay, one more I remember, recalled, that is to read engraved secret writings. Okay, if there is much hodgepodge here, so I can put all of it serial wise in the description also. But here, I know it is very messy, but still we can see all of it in one page. So it is also used in eye surgery. Okay. Okay, one more thing, ultraviolet, its bad effects are also are sometime. So we know that it produces tanning, it can cause cancer and all that. Okay, so next is X-ray. We know its uses. First use is to detect fracture. Fracture in the bones. And other thing is detective purpose. Detective, detective purpose. To see inside the luggage at airports and railways. Entrances. And last is gamma. So it is used to destroy cancer cells. It is also used in higher studies for the study of higher energies, high and nuclear and radioactivity, nuclear physics and radioactivity. So these are the uses of it. So now we will move on to understand about what is this electromagnetic wave all about.